Everyone. So this video is all about Bamford Stevens reactions, its important features, mechanism, and obviously with some interesting examples. So see, here we have the general reaction where starting from tosyl hydrazone or any aryl sulfonyl hydrazone. That means in this group, that is SO2, then benzene ring, then methyl substitution at 4 position, there may be some other aryl group also. So that is why it is written mostly tosyl hydrazone is taken, or it may be any other aryl sulfonyl hydrazone. Now this particular group, as you can see, it is called tosyl group, TS. So sometimes this compound you can write it in this way, double bond N, then NH, TS. So sometimes you will see in books it is written in this way. So TS is nothing but this group. So in simple way we can write it in this way. In presence of base, now what kind of base we take? Here we have some examples of base. Sodium ethoxide, sodium hydride, sodium methoxide, potassium hydride, these type of bases. Fine. And solvent may be two types, protic solvent and aprotic solvent. And what we are getting? We are getting alkene product. So if you look at this starting material and the final product carefully, you will see in this position, that is the position where C double bond N is present, from that position CC double bond is formed. Now this CC double bond, it will be formed in this side or in this side, that depends on the structure obviously. Now this is general molecule, so you will not be able to understand, but what happens in this case, more substituted alkene is formed. And we will also see example that how the more substituted alkene is the major product in this case. So in this way, we can understand the general reaction of Bamford Stevens reaction. Now this tosyl hydrazone, you can make it starting from the carbonyl compound. That means this part you will have C double bond O, and this oxygen it can react with this H2. There will be removal of water molecule and you will get this molecule. So basically if you see in a nutshell, you can say that as if from this carbonyl compound you are getting this final alkene, right? So this reaction, Bamford Stevens reaction, it is actually the conversion of carbonyl group directly to this CC double bond, but obviously through this tosyl hydrazone. Okay. Now some important features of this reaction. Here the base that we take, that is 1 equivalent. Now why it is important to mention? Because there is another reaction called Shapiro reaction which is somewhat similar to this reaction, and there we take 2 equivalent of base. So it is important difference between Bamford Stevens and Shapiro reaction. So that is why here it is mentioned clearly that 1 equivalent base is used. Regioselectivity, as I have said, more substituted product or the more stable alkene will be formed if there is a chance of formation of two different types of alkene, and this is thermodynamically more stable product. Stereoselectivity, mixture of E and Z, and that is why the structure is written in this way. This wavy bond, it means actually it may be E product or Z product. Both possibilities are there. So what is the mechanism of this reaction? First, the formation of intermediate diazo compound. So here you can see the structure of this intermediate diazo compound. This may be isolated, this may not be isolated. And here I have written TS. You have already seen what TS means in the previous slide. Now this molecule in presence of this base, MEO minus is written here, which is basically NaOMe, sodium salt of methanol. So NaOMe, OMe minus is the base. So this base will capture this hydrogen, because this hydrogen, if it is removed, there will be negative charge over nitrogen, and this is stable. And it is also stable because here resonance is possible with the with the H double bond O group that is present in the TS group. Okay. Now what will happen? This negative charge, there is a lone pair over this nitrogen, and if it is making a double bond, that is N double bond, then this TS group will be removed. So after removal of this TS, negative charge is still present over this nitrogen, but this nitrogen, as there is total 4 bonds, it will be positively charged. So this is that diazo compound formation. This is intermediate. Now depending on what kind of solvent you have taken, that is polar solvent or protic solvent or aprotic solvent, depending on that, we will have two different types of mechanism. So when it is protic solvent, we have the mechanism which is through carbocation formation. But if you are using aprotic solvent, then it is through carbene formation. So what is happening in protic solvent? So here we have taken methanol. So in presence of methanol, this negative charge, if it is making NN triple bond, now this CN double bond, it can capture this hydrogen. So now what will happen? There will be a carbon hydrogen bond. Fine. In the next step, this N, that is N double bond, N triple bond N, nitrogen molecule will be removed. Now nitrogen molecule, it is a very stable molecule. There is a triple bond between two nitrogen atoms. So that is why when some stable molecule is removed as a side product, obviously the reaction can move forward easily. So this is the driving force, you can say. Carbocation is already formed. Now once the carbocation is formed, this hydrogen, it will be, that is carbon hydrogen bond will be broken. So H plus will be removed, and finally we will get CC double bond. So this is the carbocation formation, that is through carbocation we are getting the mechanism. Now what will happen if it is carbene formation? When there is no protic solvent, that is this type of active hydrogen in the solvent is not present, now in this case, this negative charge, if it is making NN triple bond, there will be negative charge over this carbon. Now this negative charge, as you can see, after this step, if this carbon N bond is broken and nitrogen, that is nitrogen molecule, diatomic molecule, just as you have seen in the previous case here, N2 molecule is removed. If the same thing is happening here, now this carbon is bivalent, but there is these electrons extra. So this is basically our carbene. And if there is 1,2 hydrogen shift, you will get CC double bond. So we are basically getting same molecule, but depending on what kind of intermediate is formed, whether it is going through carbocation or through carbene, we are having two different types of mechanisms. Now if you are thinking that we are getting same product, then what is the point when whether it is through carbene or carbocation? Actually it makes sense, because though it is general structure, we are having some R or R prime, but depending on what kind of molecule is there, sometimes there may be some other types of reaction. So when there is carbocation, there may be some rearrangement. When there is carbene, there may be some CC insertion or carbon hydrogen insertion. So all the different possibilities are there, and you will see that in the examples that we are going to see next. Here reference is mentioned. If you are interested, you can go further. So look at this molecule. Here we have the cyclopropyl group. Now this NNHTS, basically you can, it is written, if I write it elaborately, it will be like this. So it is NNHTS. So in presence of ethylene glycol, which is basically protic solvent, so there will be carbocation mechanism. So in this position, the positive charge will be generated. So in the same position where C double bond N is present, there will be the generation of this positive charge, and you will get this type of carbocation, right? Now this cyclopropyl is not very stable. So this CC bond that can migrate here, you will get some 4-member type of ring. Now after this 4-member ring generation, here this carbon hydrogen bond, it can be broken and we can get CC double bond. So basically we are getting in this way the first molecule 60% yield, as you can see. Now from the first molecule, the second molecule we can get by electrocyclic ring opening. So that is why, so it will be like this. Okay, electrocyclic ring opening, it is 10%. But how this 30%, that is the last one, is generated? Basically this last product, without this cyclopropyl ring expansion, if you consider simply as if this hydrogen from this position, that is a normal mechanism we have seen in the previous slide, right? So if this CH bond is broken and there is CC double bond formation, from this wavy bond you can understand both possibilities are there, E or Z. So in this way we can get the third compound and all the yields are present. So it is through carbocation mechanism, which is clear from this protic solvent ethylene glycol. Next example, here these two starting material, if you watch clearly, you will see only difference is in this position. So chiral center is only different. So the relationship between these two molecules is their epimer. Now this epimer, again we have taken protic solvent. Now depending on that is difference in chiral center, we are not going into details. What we will get, ring expansion product we are get in the first case. Ring expansion product, as you can see, from 6-member ring, now there is 7-member ring generation. So as there will be carbocation formation, So that is carbocation formation in the same position where C double bond N is present. So obviously there is a chance of ring expansion. So as I have said in the mechanism, that what is the point if we are getting same product, if it is through carbocation or through carbene. Basically depending on substrate starting material, when there is carbocation there may be some other possibilities, when there is carbene there is some other possibilities, and you can see in this example that here ring expansion is occurring. But for the other epimer we are getting the normal CC double bond without any ring expansion. Okay, so here the first one that is actually 38% and the second one that is 56%. You will get the details in the reference which I have mentioned here. The next example, here ethylene glycol, again we have taken a protic solvent, and here you can understand how the that is more substituted alkene is formed. So this position, if you look carefully, the carbocation will be generated here, but whether this CC double bond will be to this side or to this side, obviously if it is more substituted is the major, that will be because of this methyl group present in this side. This CC double bond should be, it is more substituted. So this is 38% and this CC double bond is less substituted and it is 17%, right? Now we have this example which is aprotic solvent. So diglyme or diethyl carbutyl, this type of solvent, two different types of base combination is mentioned, but if you look at the product ratio it is almost same, right? Now this CN double bond, this position we will have the carbene generation. Now once the carbene generation is there, if you expect the normal product, that is through 1,2 hydrogen ship, that we have already seen in the general mechanism, then the middle product will be we will expect. But suppose if there is some carbon hydrogen insertion, then now this carbon hydrogen insertion, it may be that is through this CC bond formation, may be if it is happening, then you will get the first product. But if this carbon hydrogen insertion, it is happening in this position, you will get this type of ring, 3-member ring. But as these 3-member ring are not very stable, so that is why from the yield you can understand its formation, it is not very high. So in this way, through carbene generation or through carbocation, depending on what kind of solvent you have taken, protic or aprotic, we are getting different types of products. And all these examples, from all these examples, this fact is actually clear. Now this carbocation and carbene related information, if you are interested to know, I have already made some videos related to carbene intermediate and carbocation intermediate. You can click on the link right now if you are interested. And also I will give the playlist link for these two intermediate, carbene and carbocation, in the description box. So it will help you to understand the different features of carbocation or carbene, what type of reactions we can expect from carbocation or carbene. Okay, so that's all for this video, and in the next video I am going to upload the Shapiro reaction, which is very that is, there is so many similarities and also some dissimilarities. So Bamford Stevens and Shapiro, these two reactions are always discussed together. So that is why the next video will be based on Shapiro. So that's all about this video. Thank you for watching.